solve question 1. A curve has equation y equals to 4x squared minus 5x. The curve passes through the point P26. Use differentiation from the first principle to find the value of the gradient of the curve at P. Okay, at P the coordinate for x is 2 and y is 6. Okay, x is 2, y is 6. So let's use first principle. Okay, I'm going to use the delta y and delta x method. Okay, when there's a change in y, there'll be a small change in delta y. Okay, so let's start out with this. Y equals to 4x squared minus 5x. So y, I'm going to add with the delta y equals to 4. Likewise, when there's a change in x, delta x, okay, you square minus 5, and this is x plus delta x. Now expand the bracket, so y plus delta y equals to 4, and you get x square. X plus x times by delta x is 1x delta x plus another x delta x will be plus 2x delta x, and this is, oops, I need space. Okay, and then delta plus delta x square minus 5x minus 5 delta x, and delta y equals to 4x square plus 8x delta x plus 4 delta x square minus 5x, and then minus 5 delta x, and then minus y. So delta y equals to 4x square plus 8x delta x plus 4 delta x square minus 5x minus 5 delta x minus y. Y is 4x square minus 5x, so minus 4x square minus 5x will be positive 5x. So delta y equals to 4x square minus 4x square minus 5x plus 5x, and then plus 8x delta x plus 4 delta x square minus 5 delta x. Okay, now we can cancel these two. Okay, and then divide it by delta x. And that will give us 8x plus 4 delta x minus 5. Therefore, dy over dx equals to, as the limit delta x approaches 0, you have 8x plus 4 delta x minus 5 becoming 8x minus 5. Okay, now at P, x equals to 2, the gradient dy over dx equals to 8 times by 2 minus 5, which is 11. Okay. Okay. Okay, figure 3 shows a sketch of part of the curve y equals to 6 over e to the power of half x plus 4. Okay, now the finite region R shows shaded in figure 3 is bounded by the curve with x-axis and y-axis and the line x equals to 2. So using substitution method, u equals to e to the power of half x to show the area of R given by a to b 12 over u bracket u plus 4. Okay, first of all, u equals to e to the power of x. So since u equals to e to the power of half x, since I'm going to integrate between integrate 6 over e to the power of half x plus 4 dx, and the limit is between 0 to 2. And now we're using substitution method, so everything is going to be in terms of u. So I need to change the value for x, which is 0 to 2, the limit from 0 to 2, to something relevant to u. So to do that, I'm going to take u, which is e to the power of half x, and when x equals to 0, you get u equals to e to the power of half times by 0, which is e to the power of 0, and the answer is 1. So this becomes, now the next thing is, it becomes 1. And what about the next one? When x equals to 2, u equals to e to the power of half x times by 2. Cancel those two, you get u equals to e to the power of 1, or u equals to e. Okay, now let's do this, and this is e. Okay, u equals to e to the power of half x. Okay, so to do this, first of all, we differentiate u, du over dx, we get e to the power of half x times by half. Therefore, du over dx equals to e to the power of half x over 2. And since u is e to the power of half x, I can change that to du over dx equals to u over 2. Okay, u over 2. Or in other words, if I want to make dx as the subject, so it will be 2 du equals to u dx. Therefore, dx equals to 2 over u du. Okay, now sub this. Okay, sub the dx here with 2 over u. So I'm going to write this as 2 over u du, and 6 over, and change e to the power of half x with u plus 4. Okay, now multiply them, so you get 1e 12 over u plus 4 du. Okay, that's for part A. Okay, that's for part A. Okay, now for part B. Okay, for part B, I'll use different color. Okay, for part B, we have hence use algebraic integration to show that the exact area of R is e ln n bracket 5e over e plus 4. So we have integrating between 1e, 1 to e, the limit 1 to e, 12 over u plus 4. Okay, this can be integrated by using partial fraction. Okay, so since you have two roots, u and u plus 4, so I'm going to use a over u plus b over u plus 4, and this is equal to 12 over u plus 4. Okay, now times a with u plus 4 and b with u, and this is equal to 12. Now make u equals to negative 4. Okay, in partial fraction we need to eliminate one of the term. Okay, we have to eliminate one of the term to get the other term. Okay, so let's eliminate that. So when u equals to negative 4, a becomes 0, and plus b times by negative 4 equals to 12. So negative 4b equals to 12, therefore b equals to negative 3. Okay, So now next step is you make a over u minus 3 over u plus 4. Okay, and this time I'm going to make this is equals to 12 over u plus 4, and this time I'm going to make 3u. Okay, this time I'm going to make this is u plus 4 minus, okay, and this time I'm going to make u as 0, make u equals 0. So you have a 0 plus 4 minus 3 times by u, which is 0. This is, you don't need that, but this is equal to 12. Okay, so first time we made u equals negative 4, second time we're making u equals 0. So this becomes 0. So a times by 4 equals to 12. Therefore a equals to positive 3. Now let's rewrite this. Okay, let's rewrite this correctly. So 3u, 3 over u minus, okay, remember we have b is negative 3. So negative 3 over u plus 4, and this is equal to what our initial, which is 12 over u plus 4. Okay, they are same. So now our next step, I'll continue here. I can integrate 3 over u between the limit 1 to e minus integration 1 to e, and the second term, which is 3 over u plus 4 in terms of du. Okay, so when you integrate the first one, you get 3 ln u, okay, and the limit is 1e, and then minus 3 ln u plus 4 close bracket 1 to e. Okay, you have to be very careful here when you do. Okay, 3 times by ln u, so you have 3 ln e, okay, and then 3 times by ln u, which is minus 3 ln 1, and then the next step is you times them inside. Okay, so you have negative 3 ln e plus 4, and then you have negative 3 and then 1 plus 4, and the next one is u equals to 1, so you have negative 3 times okay, it's not negative 3, it should be minus, okay, I'll put a bracket first, later we can times this. Okay, minus ln 1 plus 4, okay, and then close bracket. So this one, I have to push it up a little bit. Okay, so this one 3 ln e, and this is 0, I'm going to discard that. Okay, now remember, minus 3 times by ln e, so you get negative 3 ln, okay, so this is 3 ln e minus 3 ln 1 minus 3, so this is ln e plus 4 minus ln 5. Okay, so this becomes 0, so you have 3 ln e minus 3 ln e plus 4, and then plus 3 ln 5. Okay, so let's bring 3 ln e and 3 ln 5 together, minus 3 ln e plus 4. So these two e and 5 I can multiply. So take out 3 ln e. So let's multiply. It gives you 5e, 5 times e, and then minus, which is divide by e plus 4. And rather than writing like this, we can write it as 3 ln bracket 5e over e plus 4. And that's the answer they wanted. Okay, day 12, question 3. 3 sine theta minus 4 cos theta in the form of r sine bracket theta minus alpha. Okay, let's expand that first. R, so sine theta cos alpha minus cos theta sine alpha. So expand that. R sine theta cos alpha minus r cos theta sine alpha. And if you look at the question, it says this expression can be written as r sine theta minus alpha. So I can equate this. This is same as 3 sine theta minus 4 cos theta. So r sine theta cos alpha is equals to 3 sine theta. Cancel these two. R cos alpha equals to 3. Okay. Next, negative r cos theta sine alpha equals to negative 4 cos theta. Cancel these two. Negative r sine alpha equals to negative 4. Therefore r sine alpha equals to 4. Now let's to find out alpha. R sine alpha can divide by r cos alpha, and this is 4 over 3, which will give us tangent alpha as 4 over 3. From there we can find alpha is an acute angle of 53.13 degrees. Okay, once you got alpha, okay, let's find out what is r. So this is where we use identity. R sine alpha equals to 4. Let's square that. Okay, both sides. And then r cos alpha, square this, equals to 3, and then square. So this would give you r square sine alpha square plus r square cos alpha square equals to 16 plus 9. Now r square, okay, this is using identity, sine alpha square plus cos alpha square equals to 25. Therefore r equals to root 25. R equals to 5. Okay, so we got that. Okay, once we have that, that's done for part 1, I suppose. Okay, yeah. Alpha has to be to 2 decimal places, so 53.13, and r is 5. Okay, that's done. Okay, next question. The temperature in a greenhouse G degrees Celsius is modeled by the equation G equals to 17. Let me write here. Okay, it's modeled as G equals to 17 plus 3 sine 15t degrees minus 4 cos 15t degrees, and this is between, t is between 0 to 17, okay, degrees, not squares, degrees, okay. But t is the time in hours after 5 a.m. Okay, now what is the maximum temperature in the greenhouse? Okay, what is the maximum temperature? Okay, the maximum temperature, if you look at it, okay, this part can be written as, this part here can be written as r cos, sorry, not cos, r, what was it, r sine, sorry, okay, r sine can be written as r sine theta minus alpha, and we already have that, which is not set 5, it's 5 sine theta minus 53.13 degrees. And if I plot this graph, this 5 here is the amplitude, okay, the highest point that you can get, okay, when x equals to the maximum point, okay, not the maximum, the angle, okay, which is 90 degrees, okay, when x 90 degrees, sine 90 is 1, so that's the highest point, which in this case, since amplitude is 5 times by sine 90, which is 1, 5 times by 1, which is 5, so that's the maximum point. So therefore your g at the maximum, it becomes 17 plus 5, and the answer is 22 degrees. Okay, that's the highest temperature that you can go in the greenhouse. Okay, next, the time after midday when the temperature in the greenhouse is 20 degrees. Time after the midday when the temperature is 20 degrees. Okay, now let's do this. 20 degrees. So we know r is given as r sine theta minus alpha is 5 sine theta minus 53.13 degrees. Okay, so this is can be written as the temperature. What's the temperature? The highest temperature, which is 20 degrees. So I'm gonna sub 20 degrees over here. Okay, midday, so 20 degrees. This is equal to 17 plus sorry, this is not 17 plus, this is equal to 5, what was it, what have they given us, sorry, okay, that is same as 3 sine 15t minus 4 cos 15t. Okay, so g is 20. Okay, g is 20. Can you see in the time after midday when the temperature in the greenhouse is 20 degrees? So g is 20. So let's substitute this information. Okay, so g is 20. 20 equals to 17 plus 3 sine 15t minus 4 cos 15t. This 4 cos 15t is what this is. Okay, so that is what we have to find. So bring the 17 over. So 20 minus 17 equals to 3 sine 15t. We don't have to write that. Instead of writing that, we write 5 sine theta minus 53.13. Now 3 equals to 5 sine theta minus 53.13 degrees. Therefore sine theta minus 53.13 equals to 0.6. So theta minus 53.13 equals to shift sine 0.6, and it gives you theta minus 53.13. The acute angle that I've got was 36.86989765. Okay, and then this is acute angle, first quadrant. Okay, what is the angle for sine in the second quadrant? You take 180 and then you minus 36.869897 ... and it gives you 143. Okay, gives you 143 33.13.01024. Okay, now we have two angles over here. The time, if you read the question, the time tells you that the temperature time only starts in hours after 5 a.m. Okay, but the question here, find according to this model the time after midday. Okay, they want the time after midday, after 12 p.m. when the temperature in the greenhouse is 20 degrees. So when after 12 p.m. there might be one before 12 p.m. we don't want to know that. What we want is after 12 p.m. that's what we want. So let's look at what we have. Okay, first time is theta equals to 36.86989765 plus 53.13, and this is close to 90 degrees. Okay, so close to 90 degrees theta is, so I'm going to take that and substitute into 15t. Okay, 15t equals to 90 degrees, therefore t equals to 6. Okay, so 6 hours. And if you look at the question, it tells you that t only is the time in hours after 5 a.m. So 6 hours after 5 a.m. is 6 hours after 5 a.m. is 5 a.m. plus 6 a.m. 6 hours, it gives you 11 a.m. So the first time the temperature is 20 degrees. What's the temperature? Yes, 20 degrees is at 11 a.m. But that's not the time we want. We want after midday. So we have to find what is the other angle. So we take 15t this time. We take 15t equals to 143.13011024. Add that with positive 53.13, and I've got excuse me, 196.26011024. Okay, so divide this by 15, so t equals to 196.26011024 divided by 15, and the answer that I got was 13.084 hours. Okay, 0.84 hours. So the next time when the temperature is at 20 degrees was 5 hours, 5 a.m. not 5 hours, 5 a.m. plus 13 hours plus 0.084 times by 60, which is nearly 5 minutes, 5.04, but I'll just take it as 5 minutes. So 5 a.m. plus 13 is 18 hours and 5 minutes, and if I write it in terms of time, it is 18:05 or 6:05 p.m. Okay, so the first time it is 20 degrees is at 11 a.m. and the second time it's 20 degrees again is at 6:05 p.m.